So if I'm having, in the previous class, we have discussed that first of all, when we are extracting the metals, we do the selection of ore. First of all, selection of ores. Okay, means there should be ores. From the minerals, we should select those minerals from which we can extract the metal economically. Okay, easily, conveniently. Okay, so that is called selection of ores. And and after selecting the ores, after selection of ores, what we do? We do enrichment of ore, enrichment of ores by various methods, or we can say it's concentration of ore, concentration of ores, concentration of ores. Okay, by using various method like Froth flotation method, flotation, Froth flotation method. Okay, like we have gravity separation. Okay, like we have magnetic separation. So by various methods, what we are doing here, we are just removing the impurity, the sand particle from this one. Okay, got it? You understood, everybody? So what we are doing here now, we are having four types of ores. One is the ores types. If I types of ores, we have four types of ores. One is the oxide ore. The second one is sulfide ore, and the third one is carbonate ore, and the fourth one is halide ore. So we have discussed this. Oxide is already in oxide form, and when we have finished when we have removed the impurities from these types of ores by means when we have done these steps, remove the impurities, then the sulfide ore, for example, if I'm having ZnS, PbS, they are converted into their oxide form. Similarly, the carbonate ore is also like CsCO3, like ZnCO3. So these ores are converted into their carbonate forms, and that is called calcination roasting. So here we have roasting. By roasting, we can do this one, and that we have studied this one. Okay, roasting, and this one is calcination. So we have done this one. So if we are having here, for example, C for calcination. So we have done this one in the previous class, calcination. Okay. So if I'm having this calcium carbonate, and if we heat it at 900 degrees Celsius in the absence of air, then it will get converted into calcium oxide plus carbon dioxide. Got it? Got it? Yes, you, Madiha, got it?
Yes, ma'am.
Yes. Okay. And the next one is, if I'm talking about this one, is this is calcination, and what we do in the roasting, we have this sulfide ore, and in the presence of oxygen, we heat it to ZNO, and SO2 sulfur dioxide gas is evolved. Okay, got it?
Yes.
So this is done in the roasting. Roasting is done for sulfide ore. In the presence of air, and this calcination is done for carbonate ore in the absence of air. You understood? Understood? Okay, so this we have studied. Now, why we are doing this one? Why we are bringing this oxide form into why we are bringing this carbonate form into oxide form and this sulfide form into the oxide form? Because it is easier to extract out metal from their oxide form rather than their carbonate form. Okay, got it? Now we have bring this sulfide ore. We have bring this sulfide ore into their oxide form, carbonate ore carbonate ore into their oxide form, and oxide ore is already in oxide form. Okay, and talking about this halide ore, we will talk it later. We are not going to. Out of four, three types of ores are in their oxide form. Okay. Now, what is the next step? Next step is reduction. Reduction is removal of oxygen, removal of oxygen, or or electronegative element, or electronegative element, such as Cl minus, Br minus, I minus, O minus 2. So if we are having any electronegative element and we are removing it from this one, for example, if I'm having calcium oxide and if I remove the calcium and oxygen gas like this, so this is reduction. This is called reduction, means removal of oxygen is reduction. And if I'm having NaCl and we bring it like Na positive and Cl2 gas, chlorine gas, okay, then it is also reduction. Removal of, because chlorine is electronegative element, and when we remove the electronegative element, it is also considered to be as reduction. So reduction means we are just extracting the metal from their oxide form, okay, or their chloride or halide form. Okay, you understood? Everybody in the class, please copy this one. Copy this one. What is reduction? Done? Noted this one, dear students?
Yes, sir.
Yes.
No? Or yes? Noted fast.
That's it.
Done?
Yes.
Okay, so let's move further. Okay, so let's move further. Now we are just going to discuss that is reductions. Okay, so we have discussed that reduction is removal of oxygen or any electronegative element like oxygen, like chlorine, bromine, iodine, nitrogen. Any electronegative elements is being removed from the compounds, then it is considered to be as reduction. Understood? Understood? So now I'm just writing here a table. You have to note it down in your copy. One is potassium, then sodium, then calcium, then magnesium, then aluminium. Okay, and after the aluminium, in the reactivity series that I have written previously, there was no chromium and manganese, but here we have to add these two metals, that is chromium and manganese here, and then carbon was not also there, then you have to write here carbon. Okay, and then after carbon we have zinc, iron, tin, lead. Okay, and then hydrogen, then we were having here copper, okay, writing here, just give some space here. Okay, if you're not writing in the line, so then give some space. Hydrogen, and then after we will hang copper, then mercury, and then silver, and then gold, and then platinum. This is gold, and this one is platinum. This one is silver, this one is mercury. Okay, and copper, hydrogen, you are very much familiar. Okay, zinc, fluorine, this is iron. Fe is iron, Sn is tin, Pb is lead, and chromium, manganese, aluminium, this other you almost okay. So if I'm talking about this one, that these two metals exist in the native state. Native state means they are not found in their oxide form, like or carbonate form or sulfide form. They are existing in the in their native state. Okay, you understood? They exist in their native state. Okay, and these metals are considered to be as least reactive metals. Least reactive, yeah, low reactive metals. Least reactive, okay, or we can call it low reactive. Okay, low reactive metals. Low reactive metals. Okay, and you know that they generally exist in the form of, like, if this copper exists in the form of Cu2s, mercury also exists in the form of Hgs, silver also exists in the form of Ag2s. Okay, so they exist in their these are the ores of copper, mercury, and silver. Okay, and here these metals may exist in their carbonate or sulfide form, but we have converted them into their oxide form by using calcination and roasting method. Okay, okay, done. So if I talk about this one, that is zinc, iron, tin, lead. These are considered to be as mid-reactive metals. Okay, and okay, and these are highly reactive metals. Highly reactive metals. Okay, understood? Understood here, student?
Yes.
So if I talk about this one, that is these metals. So these metals are low reactive metals, and these metals can be you can get the metals, pure metal means from their carbonate or sulfide or their forms, just by roasting. So only by roasting means heating it in the presence of oxygen, then you will give this metal, you will get this metal. So by roasting you can get these metals. Okay, understood? By roasting only you can get these metals. Okay, and if you are having zinc, iron, tin, lead, so I have placed here carbon above it. So we can say that these metals can also be, if they are in their oxide form, like by roasting or calcination, we have bring this zinc carbonate or zinc sulfide into the oxide form, like Fe in the form of Fe2O3. So okay, if I heat it with carbon, then they will be get converted into zinc plus carbon dioxide, and here it will gives you iron plus carbon dioxide. Okay, so if we are having these metals in their oxide form, then they can be reduced with the help of carbon. They can also be reduced with the help of other metals also, which are more reactive than this one, like aluminium, like calcium. So, but these metals are costlier than these metals. Okay, if I'm talking about 1 kg of iron and 1 kg of calcium, so 1 kg of calcium is costlier than 1 kg of iron. So we are not going to use that money, means we are not going to use, or we are not going to use extra money for extracting a metal that is having a low value for money. Okay, so we are not going to spend 100 rupees on extracting a metal which is costing 80 rupees. Okay, or 70 rupees. Got it? So here carbon is cheaper and carbon comes in the reactivity here. So we reduce them with the help of carbon, and it gives you reduction with carbon is called smelting. Okay, so we have to write here these mid reactive metals can be reduced by smelting. Smelting means by reduction with carbon. Reduction with carbon. Okay, okay, you understood? And these two metals, if I'm talking about these two metals, so these two metals, chromium and manganese, cannot be reduced. For example, if I'm having chromium oxide Cr2O3 and MnO2, MnO2. So if I'm having these two oxides, so if I tried it with the Cr2O3 with carbon, so no reaction will take place. And we can say that they cannot be reduced with the help of carbon. So we reduce it with the help of aluminium, which is above this one. So chromium and aluminium, chromium are costly than aluminium, so we can reduce it with the help of this one. Okay, so aluminium is being used here for extracting chromium from chromium oxide. Okay, so we can have Cr2O3 when react with aluminium, it will gives you Al2O3 plus chromium in liquid state. So this can be done with the help of reduction with carbon, reduction with aluminium, reduction with aluminium, these two metal, and this is called aluminothermy, called alminothermy. Okay, so please make this table and note it down in your copy.
Yes.
Done? Done, dear students?
Yes, sir.
Yes.
Okay. So we have done this one. Okay, now we are just going to write each and everything that right these are in the native state. So talking about these one, that copper, mercury, and silver. If I'm talking about copper, mercury, and silver. Okay, if I talk about copper, mercury, and silver. If I talk about copper, mercury, silver, okay. So if I'm having that is Ag silver, Ag2S, when you are simple roasting this one, then this can be converted into first Ag2O, and then sulfur dioxide will be released as a gas. And further on heating this one at continuous heating, what is going to happen? This Ag2O is going to convert in Ag2O is going to convert into Ag plus O2 in the form of when you continuously heat it, okay, on continuously heating, okay. So this is the first step. Then when it get converted into this form, and on continuous heating it will get converted into this form, okay. So this is by simple roasting, roasting roasting you can extract the metal from silver sulfide to silver, okay. Got it. Similar cases for mercury also. If we have HGS, when you heat it in the presence of oxygen, it will give you HGO plus SO2. And when this HGO further heated, then it will gives you Hg plus sulfur, plus oxygen gas. Hg plus oxygen gas. Okay, you understood? Understood?
Yes, sir.
Please note it down fast. Yes, Faiz. Why are you late? Just writing your
Sir,
time that you joined at 10, half an hour late.
yes, sir.
Why are you late?
Sir, my phone was not having charge. Just now I just put it.
Okay. Okay. Done? Should I move further? Noted? So if I talk about this one, next one is if I'm having aluminum, sorry, if I'm having another one that is CO2S, copper sulfide, when react with oxygen, it will gives you copper oxide, copper oxide plus sulfur dioxide gas. And like in the previous class, previous one, we were having this one that in the next step, this is going to heat. When you heat it, you can get this one. But in this case, if you only heat it this one, so this is not going to gives you Cu2, Cu and O2. It is not going to give you. It require a reducing agent. It require a reducing agent. And in this, a reducing agent is itself a crushed ore. So we will write it like Cu2O when react with crushed ore. This is itself crushed ore, reducing agent. Okay, so here crushed ore itself behave as reducing agent. Means if you alone go to the market and you bring HGO from somewhere, if you heat it, it will get converted into Hg plus O2. Sorry, Hg plus O2. When you heat it, it will get converted into Hg plus O2. Okay, but if you have Cu2O and if you heat it, you require some agent. You cannot convert this into Cu plus O2. You require some agent, and that can be carbon or some other stuff. But here crushed ore itself behave as a reducing agent. So it will get converted into Cu plus SO2. So for example, if I'm having if I'm having 10 particle of this one, 10 out of 10, 3 of them get converted into this one. So this 3 will react with the remaining 7, means to give this copper. Okay. So as soon as it is converted into this one, so this one start reacting with the unconverted ore, or we can say that the remaining ore of this one. Okay. So this process remain continue. So here crushed ore itself behave as a reducing agent. Okay. Note it down fast. Done. Okay. So let's talk further. Let's talk further. Now we have done this one, that these are the ores, and this can be reduced by simple. These ores can be reduced by simple roasting. Okay. In this case, crushed ore itself behave as reducing agent in case of copper. Now talking about these mid reactive metals, if we are having zinc carbonate. So first we convert it into ZNO and then carbon dioxide, or if we are having ZNS, then we convert it into ZNO and then carbon dioxide. So we have done this one by simple roasting. Okay, we have done this one. Now if we are having zinc, iron, tin, lead, so they must be in their oxide form, because we have converted them into their oxide form. If it is having carbonate form, then it is converted into oxide form by using calcination. And if it is sulfide form, then it is also converted into oxide form by having roasting. Okay. So this is tin, SNO, SNO2, and that is PbO. Okay. Got it? Got it? So
Yes.
if we are having these metals, so these metals can be reduced with the help of carbon. And carbon is a cheaper element, because we can have the other reactive metals also for their displacement, but we use carbon because carbon is actually a cheap reducing agent. So we are studying the uh, chemical methods, or we are studying the metallurgy, and metallurgy is an economical process in which we use those reagents that are easily available, cheaper, and gives us a low cost effective process. Okay. So if I'm having this ZNO when react with carbon, then it will gives you Zn plus CO2. If I'm having Fe2O3, then when you heat it with carbon, it will gives you Fe plus CO2. Got it? Got it? If we have having PbO, then we heat it with carbon, then it will gives you Pb plus CO2. So this is called reduction with carbon. So mid-reactive elements can be reduced to their respective form. Mid-reactive elements, mid-reactive metals, metal oxide can be reduced to metal, can be reduced to metal by smelting. Smelting means reduction with carbon. Reduction with carbon. You understood? Note it down, please. Done? Noted?
Yes, sir.
Writing. Okay, noted. Fast, Jaslin. Done? Okay. So let's move further. Now, the other elements, for example, if I'm having this one, Fe, and sorry, if I'm having zinc, uh, iron, tin, lead, these are reduced with the help of carbon that is above this one. I have placed this one, I have written this one, you can check it. Okay, and above this one is magnesium and chromium. And here it is aluminum. So these metals can be reduced with the help of from their oxide with the help of aluminum. For example, if I'm having MnO2 or if I'm having Cr2O3 chromium oxide, so when I reduce it with aluminum, so they will become, they gives Al2O3, and here also Al2O3, and here we get the metal as manganese in liquid state, and here as chromium in liquid state. Okay, so you need to notice this one, that the heat liberated during this reaction is so large that the metal obtained is in liquid state. And this reaction is called aluminothermy. Aluminothermy means aluminothermy means reduction with aluminium. Reduction with aluminium. Okay. So if I'm talking about this one, that reduction with aluminium is called aluminothermy. And we have this one react with this one, will gives you this one. Okay, you understood? Understood, everybody? No one is replying. So the heat liberated aluminium reduction with aluminum is called aluminothermy, and this can be represented. Heat liberated out during this reaction. Heat liberated out during this reaction is so large that the metal obtained is in liquid state. Okay, you understood that the metal obtained is in liquid state. Got it?
Yes.
Got it? And now you need to note one thing here is that we in the previous we have written that iron is in mid-reactive metals. So iron, if you are having Fe2O3, so it can be reduced with the help of carbon and it will give you Fe plus CO2. But Fe2O3 can also be reduced with the help of aluminium. And here in this case, we will get Al2O3 plus Fe. So what is the difference between this one and this one? And why we are reducing this one with the help of aluminium? Tell me. Why we are reducing this one with the help of aluminium? One is going to answer. Because in this case, the metal obtained is in liquid state. sorry, in this case, but here the metal state is not in the liquid state. So if I talk about this one, and means large amount of heat is being required for this one, and here the reaction is so exothermic that the heat liberated out during this reaction let the metal melt. Okay, so here we get the metals in the melted form, and this is a special reaction that is called thermite reaction, means the reaction of aluminium and the Fe2O3. This is called thermite reaction. And what is the use of this one? Let me explain you. This is called thermite reaction. First note it down, then I will going to explain this one. The aluminium iron can be reduced. Sorry, aluminium can also be used for the reduction of iron. Okay, please note it down. Then I'm going to explain you this one. When you're done, please let me know. Okay. Done this one? Okay. So let me help you. And everyone done? Okay, only Jaslin is replying. Other have muted their mic. I don't know why. Faiz, can't you mute your
Yes,
mic?
sir. Yes, yes, sir.
Madhya,
Sorry,
are you there in the class? Madhya, are you there in the class?
Yes, sir.
So if I'm asking you, why are you not replying? So this is thermite reaction. What is the use of this thermite reactions? It is being used in joining the railway track, okay, or broken machineries, because the metal obtained during this reaction is in liquid state. So if we are having this railway track and there is a gap between these two, so we used this, we make this structure like this, okay, and we fill we generally, okay, here, let's have this one here, okay, and we fill this gap here with the Al2O3, sorry, Fe2O3, the mixture of Fe2O3 and aluminium powder. Okay, so here is a mixture of aluminium powder and Fe2O3, and we start this reaction by using a burning magnesium ribbon. Okay, like we have, if we are having crackers and if we need to initiate that one, so first we burn the paper of that one, and then it is start initiating. Okay, and large amount of heat is produced during that crackers. So here also we can have the mixtures of Fe3, Fe2O3 and Al. These are the two mixtures in this one, and when they are mixed together, okay, so when we start this reaction, so the metal obtained in this one is iron, and this iron Fe2O3 when react with aluminium, it will gives you Al2O3 plus Fe in the liquid state, and this iron in the liquid state